Hey math kids, today we're going to talk about inscribed circles, and I'll show you what that is. So inscribed circle, and this is going to be a terrible drawing, but it is a circle that is tangent to 3 spots on a triangle on the inside. So it's tangent to each side, and it's inside of there. We can also talk about the radius, etc. So that would be the radius. Okay, so if we name this A, B, and C, the equation of this center point is going to be A, and so this is like little a, little b, little c. So it's going to be a times the x value of this coordinate plus b times the x value of this coordinate plus c times the x value of this coordinate divided by the perimeter. So a plus b plus c. That's how we're going to get the x value. And then the y value is pretty much the same thing, just with y's. Okay, so that's how we get that. The way that we're going to get the radius is there's a area equation where the area is 1/2 the perimeter times r, and most of the time we'll be able to find the area and we'll know the perimeter, we'll solve for r, and then we could write the equation in x minus h plus y minus k squared equals r squared form. Okay, and that's how we could write the equation of that circle. So, with all that said, I know that's a lot of stuff. Some terminology. This center right here, when it's the circle that's inside of the triangle, it's called the in-center. And I think that's all we really need. I think I'm going to zoom out and try to keep this on the page while we do this next part. Okay, so we have a circle that is inscribed in a equilateral triangle on a coordinate plane. The vertices of the equilateral triangle are 0, 0, 6, 0, and 3, 3 root 3. Okay, so the first thing I would do, I would graph it, just to wrap your head around it. So we have this, and let's just call this A, B, and C. So we have 0, 0. Then we have 1, 2, 3, 4, 5, 6, 0. Then we have 3. So 3, and then 3 root 3. So if we go here, let's get a decimal approximation for that, just so our diagram looks pretty good. So 3 times root 3 is about, it's a little more than 5. So we go 3, and then a tiny bit higher than 5. Okay, so this was C, this was A, this was B. Okay, we connect those dots. And we have an equilateral triangle, just because it was given to us that way. Now it says, what is the equation of the inscribed circle? So since it was given to us that it was equilateral, and we know this one is 6 because we can count it, we know that all of these are 6, and we can plug in our perimeter, and we can also easily find our radius. So we have a circle that's somewhere in here. It's not going to be perfect, and then some center that's about there. Now definitely don't trust the diagram on that, but if we're using this formula, we can do the area. We drop this down. We know that makes a right triangle. We can measure our height all that stuff. Actually, we don't even need to do the right triangle thing. We can measure the height. It's going to be 3 root 3. So to find area of a triangle, it's 1/2 base, which is 6, times height, which is 3 root 3. And so this is going to be our area, and this is the regular area formula. It's not this one, it's the 1/2 base times height. So 1/2 times 6 is going to be 3, 3 times 3 is 9, so our area is 9 root 3. Now we're going to take that value for area and plug it in here. So we're going to say 9 root 3 is equal to 1/2. Now the perimeter would be 6 plus 6 plus 6, which is 18. And then we have the radius. 18 divided by 2 gives us 9. If we divide both sides by 9, we get root 3 is equal to the radius. So we have one piece of what we need for our final, this formula, right? So we have the radius. Now to find the center, this point, we use this big formula. But luckily, we know all that stuff. So just to be clear, this is like my AX, AY, BX, BY, CX, CY. So that's where I'm going to get all those pieces. And we know that our perimeter is equal to 18 because it's 6 plus 6 plus 6. Okay, so now I'm going to plug into this. Let's use white. Okay, so side A, it really doesn't matter because they're all 6, right? So we're going to say 6 times the x coordinate right there, which is 0, plus B, which is 6, and then the x coordinate of B, which is 6, and then C, which is also 6, and then the x coordinate of C, which is 3, and then our perimeter was 18. Okay, that's the first piece. Now the next piece, we're going to do our A, and then the y coordinate, which is 0, and then the y coordinate of B, which is also 0, and then the y coordinate of that, which is 3 root 3, all over 18. Okay, now it just comes down to simplifying this. So 6 times 0 is 0, 6 times 6 is 36, 6 times 3 is 18. If we do 36 plus 18, that's going to be 8, 9, 10, 11, 12, 13, 14. Carry your 1, 3, 4, 5, 54 over 18. Okay. Now right here, 6 times 0 goes away, 6 times 0 goes away, and then this is going to be 6 times 3, which is 18 root 3. So we get 18 root 3 over 18. Okay. So a couple things. Let's see. 54 divisible by 18. I don't think so. No, it is. Okay. So 54 divided by 18 is 3. And then these 18s cancel, so it's just root 3. Alright, so that's our center. So we have the center, and we have the radius. And so we just need to combine those to write this equation. So we're going to say x minus 3, because that's the opposite of this value, plus y minus root 3. And that's equal to the radius squared. So if we square square root, it just gets rid of the square root. And that is our answer. Now I know that was a lot of work, but that's how you do it. So if you need additional help, please come to Math Lab. Until then, calculator.